Good morning, everybody. Cheers. Happy stream day. Did I just see a Rota pop into the chat? Hello, Rota. How are you? Haven't seen you for a long while. Oh, they've got Clippy. There's the avatar. Hi, everyone. Sorry about last week. Who are you calling a nerd? If there was ever a bunch of people that could be pointing their fingers at each other, calling each other's nerds, that would be here. Hi. How's everyone doing? Hope you're all well. Can't say I had a nice break because it wasn't a break. It's made some tea. You can take the Brit out of GB, but you can't take the GB out of Brit. Yeah, cup of tea is nice. You shouldn't be taking the Brit out of GB at all. But anyway, watch some PCB design. Yeah, well, good luck with that one. Assuming I can work out how to get this chip. Let's just say it's light on I/O, quite light on I/O, for the stuff I normally make anyway. Had toe of keto ice cream. I meant it must be healthy. Possibly. Keto ice cream. So what's in it? What is it? Just butter, flavored frozen butter. I can't say anything. I went on keto for a while. Keto is actually good. Just hard to do, hard to sustain when you're the only one in the family on it. But yeah. So we're going to be doing some KiCading today. Is OBS being what? Calcium? Why? What's going on? Is OBS okay, everyone? Can you all hear me okay? It says it on the label. Maybe it's made fat only. I don't know. Loud and clear? Good. Okay, good. Except now I need a cough. No. There we go. Okay. Cool. So, yeah, I picked myself up some of these. These are ESP32-C61. The, what do they call them? They're the R2 version, but they call it HR2. Not quite sure what the H would be for high temp, but we've only got one version. They're all H. And as many of you will know, I've already got my tiny C6 board, which is the C6 can't use PSRAM, and the C61 can use PSRAM, and it either comes with inbuilt flash and you have to add PSRAM, or it comes with inbuilt PSRAM and you have to add flash. And so I got the version that's got 2 meg of PSRAM, because 2 meg's enough, and I have to add external flash. And the other reason I did that is I can get external flash packages much smaller at a price point that won't break the bank. Then I can get PSRAM. So, and I've already got very small 8 meg flash chips here. So I went with the 2 meg of PSRAM. Apparently they're coming out with an 8 meg of PSRAM version, but it's not available yet. But it also uses no. What was I going to say? No. I was going to say it was octal, but it's not octal. So no, ignore me. Thanks, Dale. Appreciate it. Healthline.com, nutrition. I'm going to grab that link, but I'm going to not. We don't have to show it online. Chocolate peanut butter. Oh, maybe we have to show it online. Maybe. Did everyone look at that link for the keto? I don't know if I could do any keto ice cream. Ingredients: chocolate peanut butter flavor, cream, water, peanuts, egg yolks, non-GMO, soluble corn fiber, erythritol, whatever that is, allose, whatever that is, Dutch cocoa, peanut oil, milk protein, concentrated vegetable oil, gum, gar gum, monk fruit extract, salt. Doesn't sound like ice cream. Did it taste nice? I mean, if it tastes nice, fine. But oh wow, that's actually pretty good. 21 grams fat, 14 grams of carbs, and fiber. Okay, so it's less ice cream and more just a meal, a cold meal. It has all the best additives. Yeah, monk fruit is probably be used as a to help as like a thickener. Wow, that's pretty inventive. How much is it a container? $150 each? Oh, $5.29 per pint. Per pint. Pint. $9 for the chocolate peanut butter. Okay, anyway, let's move on. You have ice cream head. Oh, it's a sweetener, is it? Monk fruit, low calorie sweetener. Okay. Okay, well, there you go. So we'll close it off. I was just curious. Let's say hi to everyone in the chat before I get back into to C61 stuff. So, Embedded Hobbyist, hello, good morning. Alex Harvey, Alan Madsen, hello. I don't know why I put a T in there, sorry. Joe42. Hasn't been that long since you were on a stream, has it? Joe? I don't know. Beata, hi. David Esser, hello. AJ is here. Pew, pew, pew. Dale, Hybrid Robotics. Hello. Hello, everybody. Rota's here, as I mentioned. Johnny, hello. Bruce is here. Ice Cream Head, Bruce. Simple Electronics, hello. Sid, hi. I'm just going to go backwards now. X Micron, hello. I think I've got, no, Christian, hi. I think it's everyone in the chat. The only sweetener I can buy that isn't made in the States. Why do you buy the only one that isn't made in the States? I don't understand. Let's not go political. Your Tuesdays have been booked up. Fair enough. That's all good. All good. Oh, glad you made it. Okay, so it's been a while since I've done any PCB stuff on a stream. Hope I can remember how to use KiCad. I hope. So the reason I'm doing this now is they finally made their preliminary datasheet public. So I wasn't allowed to show the datasheet I had publicly. And so I wasn't really able to stream anything to do with the C61. And then I got distracted on other things, as I do, yeah. But they made it public. I don't know when they made it public, but it would have only been in the last few weeks. So, Mr. England, hello. So I thought now might be a time to have I don't know, there's a bit of work I need to do. So the C61 and the C6 are not drop-in compatible. Of course they're not. There's a couple of pins different and a couple of I/O numbering differences, but they've also, the pin out on the chip is different. God, where is it? So they've moved stuff. A lot of stuff is offset by one. And then they did some weird things like put the SDIO stuff, which was on the last bank of pins up top, is now on the bottom. So a lot of reshuffling, a lot of incompatibility. So I need to first start with a symbol. I did update a symbol. So I was originally going to do a, what is ESP32-C61? Who, what, where, what? Who, where? Some buffering earlier. Might be the little cable going between Oz and Canada. Could be. Could be the monk fruit. Maybe. Could be because you said something bad about the States. You dissed the States about sugar. And so they turned your pipe down a bit for a few seconds just to punish you. I don't know. Dutch Taurus, hello. Did I not say hi to Dutch Taurus? Did I see Dutch Taurus? Maybe I didn't. Anyway, so I need to. So I was going to put together a. I was going to attempt to put together a C61 Series D edge board, which I've got a started schematic for. It was originally going to be a C6, and then obviously should be C61. I apologize, Dutch Taurus. I'll say hi to you twice now. Hi. That way, you know, in case I forget next time. I don't recall seeing your name back here. No, this is the first time I saw your name in the chat. So maybe I didn't forget. Air stations on the 20-meter handband last night. Really? Cool. Okay, so what was I saying? Yeah, I was originally going to look at doing a C6 version, but, you know, with the C61, everyone likes a bit of PS RAM. There's not enough RAM otherwise. When it relates to C64, oh, there's already a new C64 anyway. So obviously, all you retro fans know all about how Commodore is now owned by new people, like the company Commodore and stuff, right? You all know about that? Yeah. It's very exciting stuff that's happening in the Commodore space. 1 gig, that's small for KiCad. My download is normally 1.4 or something. So this was the start of it anyway. It's a bit of a mess. From a board point of view, it's also a bit of a oh, what did I do there? It's just a start. That's obviously the all this is left over from the Edge S3, and I'm going to see if I can get all this in on here, but there's not enough I/O. The C6 and C61 are short on I/O, and so it might not make sense trying to put an edge board together for it. But I still need to. You can see here, I've started working on the symbol, but then I stopped, and so I figured let's just do it all on here. So I should keep working on interesting. It's not the right one. Small C61. Oh, did I not change the name of it? Or is it not in my library now? Oh, nice. Okay, so let's just manage symbol libraries. Let's just add the library. C61. Let's gotta make sure I'm updating the. Oh, that's fine. I'm gonna make sure I'm updating the right symbol. Is that not? I don't think that's the right symbol. Change. Maybe I just didn't rename it. Maybe it is and I didn't rename it. Okay, anyway, buffers all the time and goes out of live all the time. Must be because I bought premium. That's weird. So, okay, that's something out on the internet somewhere because I've got no dropped frames at all in this session so far. So I apologize if you're getting buffering. If it's too much for you to deal with, and I'll accept that, just feel free to disconnect. I won't be offended. Hello, Dinkelberg. Yeah, I don't know. It's something external. Sorry. Sorry. Okay. So I love how they put functionality like this, but they used to put the GPIO next to these, and they don't now. And then when you look at this first table for the pin overview, they don't show you all of them. You got to go all the way and find these new spreadsheet things they do, which don't even start at pin 1. Yeah. Yeah, it's YouTube or there's just a pipe somewhere that's having some problems. So I'm up to pin 13. I'm going to label these as the as the IO. I might just put that next to me. I know you can't necessarily see it, but it doesn't really matter that you see it. It's like when I'm doing it, how do I get rid of the thumbnails? I said get rid of the thumbnails. Hide. Thank you. I can get some of it on. No, okay, it doesn't matter. Okay, so I started laying this out again, as you can see. I have a 1 gig connection, but Wi-Fi kills it. What? Well, Wi-Fi can't go at 1 gig, obviously, but what I mean, it kills it. So it goes to 6. Oh. How do I, okay, wait. Let me see if I can squeeze this so we can get both. I think it's unfair that I don't show you both. If I can get them on, there we go. I can get them on. Okay, how's that? Is that good? Can everyone see? So we've got to IO6, and then it doesn't go to 8. Like, it's infuriating. So the original ESP32 had IO nothing was in order around the pins on the chip. It doesn't matter, but it makes it really hard to route stuff if you want to do a bank of IO in a row on a header when the IO on the chip is all over the chip, right? And they fixed that with the S2, and they made it better with the S3, where they had everything in order. All the IO was pretty much in order. At the higher end, there was a couple of things that were maybe different. And then they've now gone back to the whole, I mean, some of them are in order, but you go from 6 to 25, 26, 27, 28, 22, 23, then back to 14, 15, 16, 17, 18, whatever, and then down here, back to 8, 9, 10, 11, 29, and 7. Like, I get that's optimal maybe in the chip, but really, it's annoying. Okay, so let's just... I'm going to grab these and move them away just for now, because I need to grab these. And so I don't have to put this in order, but I'm going to, in order of the pin list. What's the plan for this problem? Not a problem. It's a new chip. It's officially out, but it's not officially. I mean, there's not a lot of support or no support still. It's a new chip, so I need to put together a new symbol, and I want to play with it on a board. I've got a whole bunch of chips. So yeah, that's it. Oh, what project? So well, this actual board layout is for one of my Series D edge boards. So that's my Edge S3, which is my M.2 board. I'm not necessarily saying I'll release a C61 version of this, but I'm going to look at it. The problem is the C61, it doesn't have enough I/O, so it's a bit silly maybe going on an edge board where most of the pins aren't going to be connected, or I have to stick multiple I/O expanders on just to get enough I/O, but then they're not native, right? So I might, once I've done all this, I might actually just go and make one of my tiny boards instead of my tiny C6. I'll make a tiny C61, and but for now, I just want to get all this. Like I can't wire one up yet until I've got a new symbol for it. So command data 0, 1, 2, and 3, and I want to have to change their pins, obviously. So this is 13, and it's IO 25. It's 14. It's quite funny that most of the C5 modules seem to expose only like 10-ish pins, because all the rest of them are used. Hey, Platinum 21, they're all used. So they go, what page is this? So I can get back to it easily. Where's the okay, 18. So they go like this, right? They go, yeah, here's a chip that's got 30 I/O. Yeah, no, it doesn't. It might have 30 I/O, but a whole chunk of them are used and they're not available to the user. So, frustrating. Like they shouldn't say 30 I/O. They should say how many usable I/O. Hello, Terran visitor. Okay, too fast. 18. What was 18? Okay, back to here. Okay, so where were we? So it was 26. This is pin 15, 27. Oh, 28. Whoop, no, 28. And 16. And they're not power inputs. I don't really care about when I set those. Hello, Robert Bowl. Used for what? The I/O. Some of them are used for the flash or the PSRAM integration. Some of them are used for USB access, right? Like if you use the D plus D minus, right? The built-in so 12 and 13, if you want to connect a USB connector to it without using external serial UART, you lose those two I/O. They're not native I/O. They're not general purpose I/O anymore, right? And then, or if you don't want to use those, you still have to connect the UART 0, right? So RX and TX, and they have to be connected to something, which means they're not available either. And so, they go this 30 I/O, which is I/O 0 to I/O 29, but, 14, 15, 16, 17, 19, 20, and 21 are all taken for the flash and the RAM. So they're not available. You know what I mean? It's a bit cable tie. Hello, cable tie. Are you still holidaying? Hey, Cable Tie, was it your birthday? Yeah, the order of the I/O will be to do with how they have to lay out the peripherals inside, right? Like the SDIO peripheral, maybe the best place they had it inside the die meant that it was sitting against the edge of the package here, and it didn't make any sense to move it to the other side, right? I totally get why, but it's a little frustrating that they did such a huge effort to fix that problem on the S2 and the S3, and then they've gone back to making a bit of a mess of it, right? That's all. That's all. It's fine. Um, on the 7th, 2 weeks ago, yay! So is this a birthday holiday, like a special? Was it a special birthday that you got to go on a not got to go, but you're treating yourself to a holiday? Is that what it was?
Cian, Chad has disconnected.
Okay. 22. I should not care about those. I'm just going to leave them. I'll fix them another time. And 23. 23. 18. Okay. No permanent a turn 61, if that's special. Well, the fact that you made it to 61 is pretty special. I don't think I will. Pin numbering, fix it in post. Yeah, no thanks. So these modules can almost be only used with the GPU expander or as a wireless. No, that's not true. That's not true. Not every project requires a stack of I/O. Right? You think about a little tiny LED controller that that you can control, 6 independent channels of addressable RGB LEDs within the amount of I/O that's on here, right? With the Wi-Fi and Bluetooth and whatever else. Like there's, and or, you know, just, not every project needs a stack of I/O, is what I'm saying. We'll find out how many I/O are left shortly, right? Okay, so 19 and 20. So the SPI, the CS1 and the CS0, they're taken. They're taken with the flash and the RAM. This doesn't even have a CS1, so we need to add that. So CS1 is internally already taken with the PS RAM, so that is not available. I'm going to move these out of the way just for now, and CS0 is going to be for the external flash. I need to put them back in order. It's 10, 10, 10, 10. They should be okay. It's a QFN 40, so 10 pins on each side. Should I put the right number of pins on each side? Oops, too many. Yeah, try that again. I'm going to let these overlap just for the moment. I'll tidy it all up later, but hey, Pro Engineer, good morning. Has a remappable I/O. When you say remappable I/O, meaning you can make IO4 IO6? Is that what you mean? Hey, Hubbabow. How is the economy doing in Australia? Shit. There you go. I swore on the stream. It's doing shit. How is Australia doing in general? Shit. Anyway, let's move on. Who else has popped in recently? Hey, Mohammed, how are you? Let's popped in. Anyone else? I think that's everyone. No one else new. Johnny feels like a youngster. Peter, hello, Peter. Okay, I'm distracted big time. Okay, let's move these over. So 1 and I know the order doesn't really matter where they are on this design, on this layout, but okay. So Q, W, IP, SPI, VDD, SPI, HD, clock, and good. Okay, so they cannot be used, or they are. I need to connect the PSRAM, the flash to them, but they're not general I/O. Whoops, sorry. Okay, and then we've got. See, they put GPIO 18 on VDD SPI. Yeah, VDD SPI cannot be an I/O. Impossible to map it because it is the power source for the flash or the RAM. The chip either has flash in it or it has RAM in it, PSRAM in it. I'm not talking about SRAM, PSRAM in it or flash in it. And whichever one you put in there is connected for power to VDD SPI. So there is no state, anytime, anywhere that GPIO 18 can be used. Because if you make it an I/O, you don't have flash and you don't have RAM. And if you toggle it, you're going to turn your flash on and off or your RAM on and off. I mean, that's just stupid. Anyway, remappable is great. Put the peripheral where you want. No. Yeah, ESP32 has got IO mux and a crossbar. Like you can remap peripherals, but that's not what. Right. So, yeah, Jay, all the chips have that now. ESP32's had that since the original ESP32. You can remap all the peripherals, but you can't remap I/O. You can't say IO2 is now IO6. You can say you can't. Well, at boot time you can't, but you can say, IO4 and IO5 are UART0. You can say, IO29 and IO7 are I2C. You can remap your whatever, but you can't remap IO. You can't pipe an IO into another IO and call it something else. What? Not even for other SPI stuff. What's that a question for? But there are some you can't remap. Like you can't remap the internal SPI 0 bus, right? Because that's on, it's taken, right? But yeah, the ESP32 has been able to do that forever. Okay, so 12 and 13 is D plus and D minus. 12 and 13, they're up here. Move these out the way. Okay, GPIO 24. Do I have a 24? Probably not. Let's call this one 24. I have to check all the pin numbering. 24, just pin 30. Just sell Greenland. Who? What? 12 is 28. 13 is 29. Supply and demand. If you stop eating, the price will fall. What? Who's eating what? Nowadays in Denmark now, the government wants to do something about the high food prices. You have to be really stupid to believe that. Yeah, all governments campaign on all the promises and then they all renege. And of all the politicians at the best of that in the world is our Prime Minister in Australia, Anthony Dickhead Albanese. Sorry. I'm trying my best not to make this a political stream, but oh my God, what a dickhead. Anyway, 19. Should I do this all after? 20, 21. Wait, what? It should be 22. Oh, 0 is 20. Where's 21? Pin 21. Where's pin 21? How do they miss a pin? There's a power pin. Oh my God. Okay. PS2. Right. Okay. Sure. Yeah, they can lie and they can't be punished. It's wonderful, isn't it? Yeah. Politicians, seriously. Anyway, 22, 23. You know what? I'll seriously, I'll check them at the end. I'll check them at the end. I will. 24. Okay, now we've got 8 and 9. 8 and 9, 10, 11. 8, 9, 10, 11, 29 and 7. Wait, so 10 and 11 is RX and TX. Oh, there was the other power pin. I'll put it up there. 10 is RX. And 11 is TX0. Like it was to scare the comedian. What? Oh, they're a popular comedian there in Australia that are always joking on politicians. And one night the house got on fire. So it was requested. Well, I don't know. Can't tell you. I don't know about that. But what I can tell you is, no, forget it. No. Anyway, we should move on from politics. 29 and Lonely 7 all the way over here. Okay, and then we've got, let's check the other pins here. So 40 is power. VDDA 2. Pin 40, yep. 39 is Crystal P. 38 was it Crystal N. VDDA 1. Right, and then we've got 7. 29. Yep. TX, RX, 9, 8. Wait, let me just check all the pin numbers. 9, 38, 37, 36. Nope, that should be 35. 34. 53. 231. Okay, that's that bank. 30 is 24. 29. 28. 20, that should be 27. Should be 26. 25. 24. 23. 22. Okay, 21. I know that's right. 20. 19. This is KiCad. 18. Yep, done at 3. 18. 17. 16. 15. 14. 13. Okay, I'll move them over. 12. 11. 10. 9. 8. 7. 6. 5. 4. 3. 2. Let's go back to 3. 2 and pin 1. Okay, so that is, I know it's a squish shape, but it was to fit on the schematic. Years ago and found it weird. Yeah, it was unusable. Version 4 was unusable. 5 was mostly unusable. 6 was the first version in my mind that was usable, and now they're up to 9 and they're working on 10. So it's much more like other CAD software now and its functionality and its keyboard shortcuts type thing, and it's a much better package now than it used to be. Does it have a pin table? Yep. Yeah, I'm sure it does, but you know, old school Xeon. Pretty sure that's not correct. This is a QFN 40. Oh, the footprint. Right, that's default footprint. Interesting. Have I never set that? QFN 40. Interesting that I've never set that. Put them up there. Anyway, so I'm going to move some of these over. Okay, so that's what we need a map. Practice makes perfect. It does. Like the mouse cursor snapping. I hate that feature. Oh, yeah, that's first thing I turn off. There's a lot of early choices to do with talk who into what? Jay, what did it take a long time to talk me into? Let me just make sure I have saved this into the library, because I don't think I said edit library symbol. Yes. Okay, anyway, so we now have, this is the new, okay, now it is a C61. It wasn't before. Nah. And this is the HR, well, it doesn't matter. They're all the same, but HR2. Now, this is where it gets interesting. Because all the pin numbering I've got on here obviously was for the S3. So that ain't going to work. And there's also more I/O than we had. Oh, right. Took a while to talk me into using it. I was an eagle. Mighty Eagle. I was an eagle guy. Mm, 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 mm. Go away. Okay. 4, 5, 6, 7 is all the way over here. God, this is all over the place. $29. I want to see report and block. What? How do you guys reply to people highlighting their name? You just type their name, you do at. So you type at Rob, wait, oh, at Robert Ball, hello, and it does that. So you have to type it. Yeah, the problem with Altium is just their ongoing fees. The maintenance. Yeah. Okay. I've been printing something and it just finished. Did everyone hear the printer was going before? Yes. So I'm not lonely. Okay, kind of primitive, but at least it has autocomplete. Kind of primitive. Yeah, YouTube.
Alan Madsen says pling.
Say pling. Okay. What is pling? Okay, so that is taken by the PS RAM. Can't use that one.
Alan Madsen says the sound your printer made.
Pling. Oop. Go away. Come on. Oh, 24. I'll let it just sit for a second, then I'll show you what I printed. It's so exciting. Sarcasm. It's so exciting.
Alan Madsen says problem at IO 8 and 9.
Probably. They're back to front. Yep. No, they're not. Look. They're in order. Whoops. 9 and 8. I just fixed them. Sorry. In and out. Zooming in and out. My mouse is really sensitive. That's because I chill it off a lot. Okay. Bad. Okay. 25. Thanks for pointing that out. Appreciate it. I do plan on going back through it afterwards and checking them all. But yeah. $27. Nope. Nope. Got a bit aggressive there with the finger pushing. 22. 23. Okay, so let's start from the start. Pin 1. LNA in. 3 volts. Reset. 3 volts. 0, 1, 2, 3, 4. Printer spaghetti again. Better not be spaghetti. It wasn't before. Thanks, Sam. Hello, Sam.
Dr. Nick says, howdy. Do you use netlists?
Do I use netlists? Hello, Nick. Well, these are all net lists. These are all nets. What do you mean by net lists? As in, you're talking about setting up predefined things for power and traces and stuff like that? Is that what you meant? Spaghetti in the morning makes you hungry? No. No. Okay, 3, 4, 5, 6, 25, 26, 27, 28, 23, taken 0. Wait, yeah, good. WP, SPI, BSPI, HD, clock, T-C plus 24, 8, 9, RX, TX, 29, 7, power, clock, power. Good, yay. No, I don't really. Not normally, no. Because I normally don't have fixed rules like that for power versus traces versus whatever. Most of my boards are so small and tight that it's best practice on the design rather than a fixed set of rules for, power traces can only be like this and signal traces can only be like this and stuff like that. So something new I got, what? Some LP cam 2 connectors. I don't know what they are, to do some compression modules with different chip. What? We're doing memory with a. Oh, the connectors for that RAM. I saw a video about that RAM, but how are you going to connect that RAM to, what chips are you going to connect it to? Yeah, not quite Dinkelberg. It's more like sell 20K licenses for $3,000 each. Not $300, $3,000 each. And then $2,000 maintenance every year. So I'm just looking back in the chat in case I missed anything. Okay, so let's just. It's probably going to complain. Update. Yeah, don't worry about that. Don't worry about those. Has it done? Whoa. So I told you there's something wrong with something's changed in my Zoom. Let's pin 1. So, wow, why are my pastes all offset? What? That's weird. Hello, Foo. The web license. I understand. Platinum 21. Cool. Yeah. It's an interesting interface. Okay, anyway, I'll fix those. So we got 1, 2, 3, power, yep, 0, 1, 2, 3, 4, 5, 6, 1, yep, 22, 23, yep. Good. Yep. 4, 8, 9. Okay. So that is correct. But the soldering is not weird. Okay, let me go, before we continue, let me go check the printer. So I told you it's not overly exciting, but it's a kind of necessary for me. I hope I got the measurements right. I hope I got it right. So what I just printed was it's a third JDEC tray for my Juki to put components in. Oh, bingo. Oh, yeah, baby. These are surface mount connectors. What's a good angle? There we go. That's a better angle. These are a high density surface mount connectors. And so they come in tubes, and I don't have a tube feeder on my pick and place on purpose. I could have bought one, but I didn't want one. I don't like working with tubes, vibration tubes. You lose too many feeder slots, and very rarely do I get anything in a tube that I can't work some other way of doing it. And for those that aren't aware, I made a custom I did a naughty in my Juki. Let me show you how. For those that haven't seen, I got to find the video. It's a while ago now. Juki. Where's my video on? I did a video about it. I'm sure I did. Wow. I can't find the video. I hacked my Juki and built an internal tray system. And when I say I hacked it, it's a bit of a no-no. I can't find the video. I'm sure I made a video. Didn't I make a video about it? Anyway, and so it's a thing that holds trays inside. Hey, Dishipu, and it takes 2 full-size.
Alan Madsen says, don't you have a camera in it?
Yeah, I do, but I thought I made a video about my tray system. I'm sure I did. But maybe I didn't. So it takes 2 full-length JDEC trays, so I've got a full length on one, it's got particular components in it, and then I make custom 3D printed ones for a whole range of other parts that I can just slot in and take out. And so I made one yesterday for, where did I put it? So this one here holds GPS modules, GPS and Bluetooth. They're there just for size, but that bottom one on the left, so well, my left, this one here, that's a Bluetooth module, and then the other ones are GPS modules. They're the same size. So rather than me, so these come on tape, but rather than me buying two 24mm tapes, feeders to hold these, which are like thousands of US dollars each for the feeders, I can just print a 1/3 size JADEC tray and I can place them in there and pick them from that. So it saves me buying feeders and then having feeders sitting there wasted for the rest of the time. And these are quick and easy to do. I just build them in Fusion. So the problem with this one is there are little tiny peg legs, 0.6mm by 0.6 by 0.6 little peg legs on that alignment pins. And so I had to, might not be able to see, maybe you can. Let me get the light right. Can I get the light right? No. Oh, there we go. So inside each slot, there's little holes. But I had to get the tolerance right because I can't just make them, you know, oversize them, because then the component will shift around. So it needs to be steady so it doesn't move. Oh, God, the black and lighting. Anyway, so it doesn't move and it sits flush, but it sits high enough that I can grab the cap, the pick and place cap. Anyway, so it fits. That's very exciting. And then these just fit into each other. So when they're on the thing, just like a normal JADEC tray, right? They're just like that. And then these fit into a normal tray. So a normal, you know, a tray you get with chips on them, a proper one goes in that way or on the other side. So that's why it's got that shape with the in and the out. So it's designed to match them. That's very cool. Okay, I thought I might have got that wrong. It was very hard to measure those little pins. And sure, I had the data sheet specs, but you know, with a threaded print, when you print, you know, depending on the tolerance of the printer, you either get too much fill in it, all right, or you got to open it too far to make sure it's right. But I didn't have the width to do that. So instead of doing a circle, I did squares. And if you do a circle, it'll contract. But if you do it as a square, it'll just do rounded corners. Anyway, so this is in ASA. So it's what is it? Dissipative. Oh, forget it. Hey, Mad Techie, how you doing? Okay, let's get back to cacatting. So, okay, I need to. That's U4. So I need that to be U4 because that is not the max chip. And that Y1 should be Y1, and there was a there was a 100K resistor that popped in, wasn't there? And what else? 100K resistor and the V2D SPI. That's okay, fine. We need those. But that is, oh, I hate how they've done that. They've moved, anyway, the layout's different. So all my muscle memory is gone. Okay, change. And that one. Change footprint. Okay, cool. Need to change these footprints. Like, sorry. Recently used. And do I have a new one of these? What is that? Extra 1, 2, 4. All right, maybe. Don't I have a maybe crystal? Let's see, maker. There we go. Rounded corners, change, kill. Now I need to fix this. I don't know why. What happened to this? These pads. Why these are, the solder is offset. They're deliberately on a separate layer, right? They're not part of the, that was intentional, but I don't get how they've shifted. That is bizarre. I'm going to, why can't I select them?
Super sticker!
Woo! Who was that? Foo! Thank you. What was that for? Appreciate it. Thank you, but I say plastic inherent anti-static properties, which is yes, but it's just dissipative. Dissipative? Is that the word? What's the word? Oh my god. I thought I was, wasn't I just editing the foot? I moved the footprint. I don't know what happened then. It shifted on my screen. I was clicking on the wrong thing. No, all good. I appreciate it. Thank you. Did you not know it was going to go make noises? So which ones do I want to use? Those ones. And top ones. I'm going to delete these. Delete those. I'm going to duplicate those. And I'm going to shift them. Shift M. Wait, I've got to paste them first. Shift M, and I'm going to move them -5. It's a 5mm chip, but that's not going to be right. No, okay, that's fine. Just need to, fine, I'll just do this. Okay. And I need to make all these round. Why won't it let me? I wonder what that was built with. So what is that shape? It's a square, but there is no, that doesn't exist anymore. That item, it's a polygon, but You see there, right, it must have a, even that's got a rounded corner. So what is this? Oh, it's got the 0 line width. So I give it a line width. That's interesting. 0.05. But that makes them bigger, and I don't want them bigger. Dissipative. Dissipative. That's a silly word. Thank you, Jay. Okay, I'm going to... We're going to remake these. Now, you know what we're going to do? You know what we're going to do? We're going to delete them. Bye. And I'm just going to use the pads. Except it's not something they have overridden in here. So if I want to turn paste on, I have to actually click on it, because there's no option for paste in here. Well, that sucks. That sucks donkeys, because you can't multi-select and do it. Because you can't multi-select edit. And there's no tick box for paste. Okay, so I got to double click, paste, enter, double click. This isn't frustrating at all. They'll get there. They're slowly adding more things to it. iPlate's gonna iPlate, what? What? It does 5 hours. Snags on a piece of support. What am I missing? Catch you later, Dale. Thanks for joining. I need to hire an intern. Yeah. Whoops. I hit enter without selecting it. What? It's very clickety clickety. So why hasn't anyone asked the question, why didn't you do the paste this way before? Why did you do separate paste? No one's asking that question? They will add an AI agent to KiCad, so you can just tell it to do this for you. Select and shift insert. There's, what do you mean? Shift, and there's no repeat action. Repeat action on there'll still be multiple clicks even if I did. You do this all the place this way. Did I do that one? No. So these footprints were set up a long time ago, and they were before I had my stencil printer. And so I used to have to over lengthen pads. You would have seen that it was longer, and it didn't start at the edge, but it went further. So I had to do that to compensate for the paste that was pulled out of the pads depending on the direction from pasting, because it was all manually pasted, right? So even though I had my vacuum bed thing and whatever else, there was no way to do perfect, consistent pressure across the whole thing, repeatable across every single time, every single panel, when I'm doing it manually with my hands. So I used to get issues when through that, where it would I'd pull the paste back out of the pads when I was pasting on the stencil. Sometimes, not always, but when it happened, if it happened on even on only 2 or 3 pads, but on various ones on a panel, the whole panel's kind of gone, right? So there's no point manufacturing a panel of boards where you got 20 on the board, 20 of these ICs on the board, and 4 of them have got a random pin that has a problem. But when I got my stencil printer, my auto stencil printer, all those problems went away. And I get on my stencils nano coated now, which is just magic. And so now there's no chance that paste stays in the pin, like in the hole, or gets pulled out or anything. So yeah, but that's why I've got, you know, a lot of things that don't have round edges. You would build your own footprint. I did. This is my own footprint, but I built this ages ago. So stencil maker, a fiber laser cutter. I don't know what they use, to be honest with you. Right, but none of that's necessary anymore. That's so there was a lot of all the IPC standards for this pitch, for this type of paste, for this type of whatever. There are too many to cover all the different. Sorry, there aren't enough to cover all the different production environments, right? You need to tune the design for your production capability or for the manufacturer's production capability, and not to an IPC standard, right? An IPC standard is a guide, and if the production facility says we need all of the footprints with this IPC standard, great, you do that. But for me, all my footprints were tuned for my manufacturing capability, like for you know, whatever issues I had with my stenciling, all my footprints were tuned for that. And slowly over time, I've gone back and I've cleaned a lot of this stuff up. But you know, it's been what, 2.5 years since this footprint was made. Actually, no, this footprint was made before the C6. This was actually from something else that I made. And so, yeah, it's just not, we need an update now. Anyway, so we now have curves, and everything else. All my footprints now are, I have to fix that one. That was one that got through, but all of my footprints around on the pads. Anyway, so we need to squeeze those into the center here. But again, I don't think putting this on this board makes any sense, because I'm not going to have enough IO left at all. So here's the thing. What have I got to work with? I'm going to, how am I going to, besides doing it yourself, it's a lot less expensive and probably effectual to having IPC. Probably. Well, all my stuff could be IPC standard now, like default, but like even a lot of the default footprints in KiCad and the default footprints that used to be in Eagle and whatever, they're not what I would use for my manufacturing. So like I tune, like you look at my 0402 components and the pad sizes and shapes, they are smaller and tighter than what the KiCad ones are, because I know I can do that, and it means that it takes less space on the board. So I'm not going to do a footprint that has a pad that's, you know, I'm just whatever, but you know what I mean? Like, that's like that in size when I don't have to, because all I'm doing is removing trace space where I can get traces around. Hey Quindor, how you doing? Yeah, to optimize production, optimize for space. I've actually got some footprints that are way tighter than this as well. But yeah, no. So let's go back just here. How am I going to mark which ones? How many I've got? So what are the that's what I didn't check. Are the strapping pins the same? Strapping, fine, strapping. Okay, we really need to shrink that down. Okay, strapping pins, floating, okay, 7, 8, 9. Okay, 8, 9 for chip boot mode, driving clock. Okay. Well, see, there you go. So you're going to be super careful. So there are 5 strapping pins, strapping IO, and obviously, so IO 9 is what like IO 0 was on an S3 or an S2 or original ESP32, where that defines if it goes into download mode or not. But 8 and 7, and then what is DI? 4 and 3 are also strapping pins that you leave floating to have them not influence anything. But if you don't have them floating when it boots up, so if you connect a button, for instance, to IO 7, no, let's wait, which one was the sensing? If you put a button on either MTDI, MTMS with a pull down or a pull up resistor on it as a default, right? When it boots up, that's going to influence what the driving clock edge and sampling is going to be, because it's going to read those inputs at boot up. So there are four IO, 8, 7, 4, and 3 that you can't have anything connected to at boot that isn't allowed to be floating. So it can go to a GPIO to a header, but it can't go to something that is going to pull it high or low by itself. So that's more strapping pins than before. So going to the header, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 IO. Now, just so you know, like currently on the Series D, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I counted D plus 1, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. There's 29 plus an IO expander. And now we've got 20, but that includes IO that is being used for other. So I've also got IO for the reset on the IO expander and the interrupt on the fuel gauge and the interrupt on the IO expander. So that's 3 that aren't on the header and that have to come from somewhere. Plus, is there more? I need one for the select pin for the RF switch. So I lose another 4 at least. So how many did I count? Let's not count it with D plus D minus. So we've got 1, 2, 3, and I can't use these. No, that's okay, they can go out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20, but I lose 4, so I can only break out 16 IO. Which means that's a lot less. That's, yeah. Sure, that's a good idea, Fu. I'm less worried about the strapping pins. It's more about how many IO we're going to have broken out.
Soon, Chad has disconnected.
Okay. It's back. Cool. So, hang on. No, we also need... okay, and here we don't need the V-bus check. So what I'm thinking is, I think I'm going to grab that. I'm going to copy that. So I'm going to, where's my KiCad? I'm going to go here. I'm going to open project. C6, tiny C6. Yeah, so many things. I'm going to save that as tiny C61 R1. And I'm going to paste that. Delete. Oh no, I missed my labels. That sucks. Oh, that's annoying. I thought I had them all, but I didn't. So it makes no sense to make an edge C61 right now, because it's not going to have enough IO anyway. And copy, paste. Missed one. Copy, paste. Okay. Hey, half Greek geek. So yeah, I'm not going to be able to make a full board out of it anyway, and it's going to also be hard to test and stuff if it's just a half an implementation. Oh yeah. What? Your HDD blew up? TV exploded? So what happened, Bruce? Did one device take out another device, or was it something else, something external? So even the IO numbers are totally different. Okay, I see one. Oh, wow. What? What did I just label it? Did I just mistype it? No, I see one. Okay, why won't that hook up? I see one. Oh, what? QFN40. Why does it say 56 pin? I don't know. I see B. B and A, really? It's complaining about these two. Value. Right, I just need to get the values the same. I should have copied both of them over. I should have just imported it. I should have done it. Update. Okay, don't worry about those. Okay, so that's the new mapping, which of course is going to have a bit of a problem because I've got traces going to it that aren't right. Like IO9 is actually now 27. But I wonder if where's 12 and 13? They're over here. So D plus and D minus that was there. Oh no, it's over here. Jesus. How am I going to get that out? What a stupid place to stick D plus and D minus. So on every single one of their chips so far, D plus and D minus have always been in this section here. Always. Not necessarily on those two pins, but within this section here. And now, catch you later, Alan. Have a good sleep. Oh, it's getting cold in here. I need to put the heater on. And now they are not. They are in a very awkward place. I have to somehow get I/O from here. Well, let me do it. There's something else touching it. To the other side of the flash and around. I mean, I can do it, but I've got this whole. Yeah, anyway. That's annoying. As I said, it's very not drop-in compatible with the C6. Update footprint from library. Did I not save that one? I didn't save the footprint that I fixed. silicon that way and limit the length of the bond wire. Yeah, I know, but they yeah, frustrating nonetheless. So I'm just saving that footprint that I modified. I forgot to update it in the library, so I'm doing that now. So now I can update it, and that's the new one. Cool. As you can see how old this is. This has got old footprints, square pads on these things. It's quite old now. Okay. So I need to fix the this is not going to be so easy. At all. So theoretically, some of them I can just go and, you know, I need to keep this bank together. The only way to do this is to just start renaming the headers, the pin numbers on the headers. So I need this one here to be, well, I don't know what I need it to be yet, but I need to group these together. So 23, 22, 28, 27, 26. Why don't we start with that? 20. 23, 22, what was it? 23, 22, 8, 7, 6. Oh my God. Let me just fix that. That's really annoying. They are not used. So they were old fiducials on the board when I used to have to do it. Hey, Tony. Hey, mate, how are you? When I used to have to do it on the per board fiducials on the Neoden because it couldn't do panel-based fiducials without getting the maths all wrong. Okay, so where is 8 and 9 now? 8 and 9 are down the bottom. So can't use those. So no, that one. I'm gonna have to swap those around. 8 and 9, so we're going to actually make them 6 and 5. So it's really good that my C6 and my C61 are going to be in no way, I mean, header-wise they'll be compatible, but no way will they be I/O compatible. Frustrating. Okay, so you go away. 6, grab it all, go away. That one, go away. That one, buy. I'm just hitting U, keep hitting U to expand to do, wait. Yeah. I don't even know if I've got enough IO to do these, to be honest. We'll see. So just for now, 5, 6. This is not about good routing. Wait, did I get the order wrong? 25. Did I miss one? 23, 22, 28, 27, 26. Oh my God, I missed one. 26, 25. Okay, that's IO 25. And that's IO 6. Oops. Try that again. I'm old, tired, and cranky, so all good. I understand. I really do. Okay, so what? See, 0, 1, 2, and 3, 4, and 5. I can't get them around to the bottom easily because I don't want to pull them to the RF. And I could have dragged them all up and done them along the header, but then I've got no place to stick these. There's no way around just deleting all these and, oops. I have to get 9 from here up to there. Or I bring reset up and put 9 down. But I need reset down here anyway. And they're fixed. I'm not going to change their header positions if I can get away with it. And then RX and TX are on the wrong pins. Where are RX and TX now? Right, they're here. So okay. I know that's ugly. And that's not 22 and 23. That's 7 and 9. Floating 29 for power. Forgot about power. That's going to be a problem for the LED. That's IO 29, just because they're already there. And data in will be floating, IO 7. That could be sort of flickery on boot, maybe. I just want to see if I've got enough IO, if I can even match this out. I'm not sure. So that's the LED. 9 and 8, 24. RX. Okay, I've got. Boy. And I need for here, I need 2 IO for those. Okay, so they are not going to be up here. And so I can bring I can bring those around, but I can't cross over here. How am I going to get these? That's going to be an interesting challenge. I don't know what IO is going to go there, but I'm going to get IO out to there. So IO 0 was normally up here. I guess it doesn't matter. I'm going to have to bring. So this is normally SPI. So 1, 2, 3, 4, like a CS pin, and then I2C, and then these two are just whatever. The other thing I need to consider is which. Oh, that's interesting. I think there's only one ADC, isn't there? Is there any ADC? Analog. That's power. Mux. So which pins are ADC? Which are RTC? So this is a preliminary data sheet, right? So it's missing a whole bunch of stuff, which is why I said in the description, it's too early to be doing this. What does minimum trace width you can work with? Hey, unis, I hope I got that right. Or it can be whatever. I don't normally go lower than 0.127 millimeter. I do mine in millimeter, whatever that is in mil. But yeah, I try not to go any thinner than that. So is there no ADC? Oh, hang on. Right. Oh God. Consolidated pin overview. They couldn't have just got to that before. Oh, man. Hide. Don't know if you can see that. A bit hard to see. Here, ADC. Wow. There's only 4 ADC pins. And they are GPO 1, 3, 4, and 5. Wow. I need to get MTMS. I need to get those all the way down to here. So normally JTAG is here on the headers, on the chip. So what was it? JTAG is 3, 4, 5, and 6. Where am I going to put them that are grouped? I can't. I don't have a place to stick grouped because for compatibility with my other boards, these have to be they are SPI and they are I2C, which leaves me 2 IO here. Okay, cool. Thanks. Yeah, I don't do mill. I stopped using mill when I stopped using Eagle, and even in Eagle, even though it kept defaulting to mill all the time and it wouldn't stick the setting, I was trying to use millimeters. We're decimal here. We don't do imperial. Like, I couldn't do inches if you. Yeah. No. So I don't know how I'm going to do. So I can't break out the JTAG pins as like a group for JTAGs. That's fine. So that's not going to happen. So if that's the case, and according to the ADC pin, I need two ADC pins over that bottom section. Wait, then where do I put 8 and 9? I need to break 8 and 9 out. This is bizarre. So I don't have enough header space to break out the pins I need if I want to allow people to use SDIO functionality, or so 8 and 9 are not ADC pins. Wow. So I'll have no ADC pins broken out. Because if I put 8 and 9 here, these two here are 8 and 9. I can't put 8 and 9 up here because I've got those broken out. And 8 and 9 can't be I2C. So I can't use them there and I can't use them here. Yeah, but mill's not easier because the measurements for everything else isn't in mill. Like, the pitch for pins on an IC is not in mill. And the width of the pin on an IC is not in mill. And the position of a part on a board is not in mill. So I get what you're saying. But it's no, but it's not that they're omitting. Well, I don't know. I've never seen an IC that tells you its pin pitch in anything other than millimeters. Never. Like I've never seen one, or a connector, or anything else. I mean, maybe well before I started with electronics, before I started back in electronics, which is really only when was that? 2017 ish. Then, like, maybe before that there was. I don't know. Maybe I just didn't notice it, but I'm pretty old, but I took a very large gap from electronics. Only came back in 2017 in it, but and you might be older than me. I don't know. I don't know what I'm going to do. I don't see. So I can't make this compatible. If I make this board compatible with my other tiny boards, so you can just, you can take out a tiny S3 and put in a tiny C61. So when I say compatible, yes, any I/O can be anything, right? I get that. Any I/O can be any peripheral. Almost any I can be any peripheral. But I'm talking about I'm talking about for this. Matching is more difficult to to switch. Have machining. Oh, sorry, machining. Yeah, machining. They still do machining in. Yeah, I know it's frustrating. Documentation. So I'm talking about. So these are all my pinout cards for my boards, right? So with my pinout, so this is my tiny S3D, right? I always have the functionality of the pins in the same place. So yes, any IO here on the headers could be I2C, but these two positions here are the default I2C, not the default in hardware, but the default in all of the support files that I make. So like if you open up an Arduino project and you say, connect this to, I want to initialize I2C for this device, it's going to initialize these two IO because they are the default inside Arduino for this board. For all my tiny boards have I2C here, they have ADC 1 pins here at least, and they have these ones here for SPI. So if I didn't do that, if I put IO here that can't be those, like you can make 9 and 8 I2C, but 9 and 8 are strapping pins. So you can't put pull-ups, for instance, on either of them because that'll make the board not boot. Is adding another... No, it's not a routing issue, AJ. And you can't just add another layer. That doesn't work that way. But no, the issue is not routing. The issue is, when I say you can't add another layer, I mean you go from 4 to 6. You got to do them in pairs. Or unless you're going to get totally custom boards manufactured at insane prices. Okay, then we use millimeters. Right, I'm going to visualize fraction. Right, okay. All good, Sam. All good. So I need it to be drop-in compatible. Like for me to stick the I2C pins over here on this side would just not make any sense because then you couldn't interswitch. And that's fine if it wasn't a tiny board, but all my tiny boards do the same thing, right? They all, so I go down to, here's my tiny C6, same thing. I2C on these ones, SPI is over here, right? RX and TX is over here. Type, all the way back to my tiny Pico, I2C is over here, SPI is over here. It's I've got too many tiny boards that use the same layout. So I'd have to call it something else and make a different board. Or yeah, I don't. And the issue here is that the ADC, or partly the ADC, and I could just not care about the SDIO, right? I could not care about this, and I could just get rid of 2 of them, and I could put 8 and 9 back up here again, even though it's pain to route because it's on the other side of the board. But I could put 8 and 9 back up here, like I already have on my tiny C6. 8 and 9. And it's not imperative that those strapping pins are in that position, but I have IO0 at this point here on my boards as well. So, which is the boot pin like IO9 is. Oops, wrong one. Right, IO0. So if I put 8 and 9 back up here, and they come from here, that's fine. I'll work it out. It just means that then no one can use the SDIO interface. Or they can only do 1-bit or 2-bit. I don't think you can do 2-bit. Can you do 2-bit? I think it's only 1-bit or 4-bit. So you could stick an eMMC chip on here, but you could only do it in 1-bit mode. That's really annoying. So it'd have to be 9. That would have to be 8. Whoops. See what happens when you design yourself into a hole. You make a decision 5 years ago, and now it comes and bites you in the ass. I'm just being silly here. Let's just see what I can... Just curious about...
Intermit Tech says I get that issue.
It's annoying. Also, these traces are going to be old and wide. Yeah, okay. So we need to upgrade some of these traces. If I don't need 127, I don't use it. But now I do. Whoa. That was just a double delete then. I don't know what happened then. So I need to get these two out. 127. Okay, I need to get this one. Yeah, whatever. Look at all the hopping. These aren't being used, so really. Okay, so 8 and 9. I still have to get D plus and D minus. And I've got all this IO around here. I need to get 2 of these over. I need to get 3 and 4 down to here. And how am I going to do that? Because I need to get they're my ADC minimum ADC pins. Yeah. I think my mouse is dying. Something wrong with my mouse. That's why it's moving so quick. Or something, because it keeps doing those weird things. Really? Yes, I know, it's ugly. It is very ugly. Super ugly. But I just want to see if I can get them there. Where's my minimum spacing? Still can't get that through. Okay, so they could be my two ADC pins. What the hell? They haven't fixed. This is KiCad 9.4. They still haven't fixed that bug where it just does little funny things inside the traces. How long have I been streaming for? Shit, over 2 hours. What? Okay, so if they came down to here, 3 and 4. IO3 and
HMS says
IO4.
mega stream.
Well, not mega, but unexpected. I wasn't expecting. Oh my god. Wrong way around. Yeah, like it's I've done bigger, but I thought I guess I assumed I would have already rage quit by now. Oh my god, this is so annoying. Okay. Seriously, I shouldn't be fixing these things now.
Dinklebird says unexpected stream from unexpected maker.
Sure, yeah. That's why I can do that in there. Yeah. Okay, anyway. So then I got 8, 9, I got those up there, and then I've got. So let's just go back to the starter sheet, because if I'm putting the SDIO pins up there, they're just general purpose IO. So where are the RTC IO? Which one's the RTC IO? Hello? What the? It doesn't specify. RTC IO? Is there no? Alan! Hello! What's doc bug? Yes, I need to call you back. RTC timer. RTC GPIO pins. In tables on this chapter, some pin functions are highlighted. The non-highlighted GPIO or RTCIO pins are recommended for first use. Pins are needed. The highlighted GPIO RTC. Okay, so where are the RTC? they reference it, but then there's nothing. There's no. GPIO. That's it. 4 references in here, and no reference to which pins are RTC/IO. Or there isn't any. What the? Okay, I'm just going to go grab the C6 datasheet. A version of the C6. I don't know what version I've got. It's pretty old. Yeah, that's pretty old, but still. Okay, this is the C6 datasheet. And let's find RTC GPIO. What? Okay, let's just not do that. Let's find the pin list. This is a very old data sheet. This is from 2023. You don't want a crown, you want to be normal. The idea how to fix the S3 USB drive issue in Windows. I didn't know that was even a thing, Tony. There's been quite a few problems with the with ESP tool and with the latest versions of the Arduino core and USB or the enumerating not working properly. Sorry, I'm RTC. Are there no RTC/IO pins on the C6? Or is any low power I/O an RTC/IO pin? This is mind-boggling. Where's that big pin sheet? Somewhere near the bottom. Wait. Mention here, low power you aren't. Power squared C. So you can see the difference in size of the data sheet, right? The other one is very preliminary. What do you mean? I am in the design process. There is no schematic. So I know old school process is a schematic is designed fully first and then board layout. And you could have independent people doing that. But that's, hey, wagon loads. Yeah, you're late. But that's like, yeah. Medieval thinking, right? There's no such thing anymore as working that way. I mean, you can do it, but you know that assumes that the board layout is not important compared to the schematic. And in my case, the board layout is more important than schematic because my board layout has locations that have certain requirements, and those requirements will require a certain type of I/O, and I'm going to pick an I/O that's closest to those pins, right? Yeah, no, I'm just, you know what I mean? So I get the old school mentality of the product gets designed at the schematic level, right? And then you build a board out of it. But yeah, for me, they're both the same. They both happen at the same time. Because so it'd be different if it was a board that was going inside of something that no one ever saw, and it didn't matter. No one had access to the board, right? So it didn't matter where I put things on the board because it was only there for my own use for that product. But the stuff I make is user facing, so it's people use it, and where I put things on the board can help or hinder those people, right? If I make really bad choices on where I put things and they're not easily accessible or they don't make sense when you're trying to connect things to it, then that's bad, right? So I can't do one without the other, that they have to happen at the same time. Hey Liam, how you doing? Right, if you need to design a board that's going to connect to something else that has a very specific requirement of pins, that's fine if those pins are just all generic. But if they have functionality requirements, and then you've got something like, you know, one of these C6s or C61 that have very specific, like the fact that there's no analog on a whole range of pins, and those pins' physical location have to be analog, then you need to know where they are on the board to know which pins you need to choose and how many you need and stuff like that. But with all PCB design stuff, when I say PCB design, schematic PCB, you can't design a PCB without a schematic. So when I say PCB design, I mean the whole thing, right? There are so many different ways to skin a cat. There's no requirement to do it in any particular way. I don't understand. If I go back to my C6, right? Look, my C6 has no RTC/I/O pins. So if you look at my here, see it's got RTC/I/O. So for those that aren't aware, an RTC/I/O is an I/O that can be used when the device is in deep sleep or any form of sleep, right? You can, if you want to do something like awake from touch or wake up the chip when a GPIO toggles, they have to be on an RTC/I/O pin. So you could not wake the S3 from sleep on IO35 because it's not available during sleep. I have totally forgotten that there are no RTC/I/O pins on the C6. Well, that makes things easy from a design point of view because I don't have to worry about making sure I have some broken out. Bad migraine this morning. Feel a bit better now. How you doing? Sorry to hear, mate. I think I had my first maybe not my first, but it was a severe last week. And Yuz actually suffers a lot from them. She's on that medication, that expensive tablet, migraine, non-government subsidized thing. So yeah, she suffers from them a lot. Richard, hello, Richard. How are you? Okay, so I don't need to worry about that. So then if that's the case, I need to pick some IO for this and for that, and I can't get the IO out because 8 and 9 that have to be brought up stop me from bringing the other IO around. That really sucks. Because I can't bring IO through the crystal area, and I can't bring it through the RF area. And that I can, and of course, if I bring it all through here, I've got no vias on my big ground pad. Holy schmoly. Actually a problem. This is actually a problem. Wow.
Super chat.
Thanks, Matt. Coffee. No, I loaded 04 yesterday. I've been using 03 up until then. I can't give you feedback on 04 because I've only just today's the first time I've been using it properly, other than just opening up something and checking something. They've mostly fixed that the weird routing wobbly pin, where it was creating wobbly things, but it's happened a couple of small times for me in this session. But not nowhere near as bad as it was. I don't know what I'm going to do here. No, I can't rotate the ESP32 chip because then I can't do my RF. The RF is extremely important. So I can't have the RF come out the top and the RF can't be on the other side. So yeah, that's not really an option. That pin there is dictating everything. And again, the C61 is the only chip I've used so far that has this problem. Even like the C6 things were in other places. Things were in similar places, so it didn't cause a problem. Yeah, it was a pain in the ass for me as well. It was, I hated it. It is better, but it still does it. Like you can still, if you go like this and then you bring it back, sometimes it won't fix it and sometimes it'll be in pieces still. But it's definitely better, like you saw then. So, yeah, my VNA is fine. Look, they fixed half of the bugs in a firmware update, not all of them, but I've got a workflow on it and it works. Like all my boards have been tuned on that. But yeah, it was still a disappointing thing that happened. Well, it's not about easy. They all have to be tuned. They all require matching networks to tune. So a PCB antenna is cheaper, but takes 20 times the amount of space. You can't get a PCB antenna that big, right? A PCB antenna is that big. So that would be like I can't put a PCB antenna on here. And they all need tuning. So when you say easier, there's no easy with RF. Sorry, hate to burst the bubble, but there's no easy. What? What other nets? Oh, right. They're all different. They're in the wrong spots. Nice. Nice, Sion. That would be why it didn't like doing that. Okay. I mean, is error tolerant or must be? They've all got to be right. You they have the same challenge. So RF has to be right. Otherwise it'll, well, it doesn't have to be. Like it'll underperform, but it can damage your chip. A badly tuned RF that reflects the signal, like, 100%, will burn the chip. It'll the current chips, like current ESP32s, they do a good job of, holy hell, how am I going to get that out? They do a good job of detecting and shutting down the RF, but they can also not detect it quick enough, and you end up blowing the chip. Like, you got to be really careful. You're pumping a stack of power back through the chip if it reflects. So yeah, it's got to be tuned. Like, yeah, that's interesting. How am I going to do that? I know it sounds like I'm talking to myself. I'll explain what the issue is in a second. Let me just okay. So I've got a 3.3 volt pin here, which is VDD. Okay, so it's not an analog; it's a digital pin. But I need to not only get 3.3 volts to that pin, so a wire, but I also need to put a decoupling cap on it. So so this is a pull-up on the CS0 going to the flash. This is the V2D power, SPI. So this is 3.3 volts coming out of the chip. This is not usable for anything else, although sometimes I hijack it. That is a decoupling cap for the flash. I need to get a decoupling cap in here for that pin, and I need to get a wire to get to it, and I guess I'm going to have to go janky here. Oh God, so it's still doing stuff like that. That's really annoying. Where am I going to stick another cap? See, see what it did here? You see that? Matt, you watching? Okay, didn't do it that time. You need to you use a VNA, minimum of a VNA to tune your antenna, or to tune the components for the antenna. Yeah. VNAs are pretty cheap now. Like, you can get cheap ones off AliExpress that they go up high enough. Like, they say they can do like up to 3 gigahertz or 5 gigahertz, but they don't do them well. But it'll do them well enough to give you a guide. So I'm just wanting to see if I can get these lower. It's better, but it did that janky thing just a second ago, which was really frustrating. I need to get another one of these. It's going to be C4. I'm just going to grab one from here. Just for the moment, I'm going to stick it there. C4. So if that was there, don't tell me I can't move it. I have to put it there. It's too close. Yeah, they did. The mini modules, the original mini modules they had for a lot of them, including the S2, were not tuned very well. That is true. So I can do something like this. Okay, so we've got that there, and then this can come. Well, that's fine, they can go like that. Like watching sports, I can yell at my screen. What are you yelling at your screen for? This is not a final design. This is just me saying, like, that was, you know, I didn't have to go to that extreme. But I'm seeing what I can do in terms of, like, so now I can get this out here. And because I can get this here, I now have more room to get these up. You know what? Oh, this is going to be... I don't think I should be doing this, but oops, but I'm going to try. Can I get that up in there? No, not. So 1, 2, 7 bits. Can I really not get that up in here? Can I not get a via in there? Surely I must be able to. Oh, look at that. Oh, no. So close. That is annoying. So you know how you fix that? I'll show you how you fix that. Show you how you fix that. You go on the footprint and you make this pad a little bit smaller. 2.5. It's really going to make any difference to the thermals, really. But now, check this out. Now I can go to do this. Oh, wait. Is that still not fitting? It fits. There you go. So if I bring that to there, then I can bring, I know, terrible, forget the routing. It doesn't matter about the routing. It really doesn't matter. But what I get is, I get not as much as I thought. Really? Anyway, I thought I got more space. Let's get some of these vias back in place. So we can just see if we've got how much room we've got. I want to see how many I/O I can bring around. How many I can squeeze through here now. I've only got that much width, but that's a little bit. Can you give big pad 45-degree corner? I can, but that's not going to help me now. I just needed a little bit. I mean, at the end of the day, what I need to do is get these blue traces as far away apart from this as possible. Because I need to get some of these I/O all the way over to here. I need 1, 2, 3, 4, 5, 6. I need 6. Which are the low power I²C? Hang on. So there is some peripherals that can't be moved. So there are low power I²C. Okay, where are they? IO marks, functions. They can be low power IO marks. Are they're not fixed pins for I²C? So the C6, I don't know about the other smaller chips, but the C6 it's got a high power and a low power core, and you could run there was 2 particular pins that could be I²C in low power mode, but you couldn't move it on the mux. They were fixed. It looks like that is not the case now, and there's a low power mux instead. So those I/O can be, you can use those for functionality in low power. What is your via size? The vias are the smallest they can be, or like this one, for instance. The smallest it can be before I hit a cost penalty at JLC. So that size there is based on cost. Can you hear that? What the hell was that? Catch you later, Tony. Good luck. IO outside the chip, top left, and then IO9 to where IO8 is. No, because I still need to bring out D- and D+. So if I have 8 go around here, I block off these 2. Right now, these are free. These need to come out somehow and around here, which means they need to be on the back. So somehow, whatever, I need to get them around and back up to here, and this one as well, which already I'm not going to be able to easily do. I'll have to move this over. But so once I put those in, I don't have the ability to get around. I can't do a top layer trace through here. It'd have to be a bottom layer, and I won't. I mean, even if I had it, maybe a little. Well, putting 9 to there, it's going to go from this much space to that much space. It's not even going to be one extra trace, I don't think, but maybe. Up and left. I can't get it up and left. You can't route through here. Sorry, through here. No. That's very, 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 very bad PCB design. Don't do that. Don't route through corners of QFNs. If you can't find another way, then change your design. Yeah, that's. I won't do that. Been there, done that, suffered for it. Don't do it. Yeah, getting a trace through there. Nature of the corners and stuff. Yeah. But either way, it's not going to save a huge amount. And by the way, if I had it go through here, then I still can't put 9 where 8 is because I've got a trace through here. 9 would only be able to go from there to maybe there. It's not going to save anything. There are footprints that are designed for that. No, the footprint's designed for it, sure. And in the past, I would, to compensate, I would make this pad, for instance, a little bit shorter. It's not going to let me do it here. Or maybe. I'm going to regret doing this for now, but that's okay. I'm just going to show you. Okay, that was too much. I'd do something like that. You see how it's shorter? To give myself more space. But it's not worth it. It's not worth it. But if that wasn't there, and this went here, right? This can still only go to there. Otherwise, it's too close. So I've not saved anything. Not saved enough. It's not worth the risk. Blue across the square pad. I don't want them blue. You mean through here? No, I'm trying to free up so I can get traces through here. I need to get 5, 6 traces through here, and I can't. I'm going to get 3 right now. Is all I'm going to get. So I'm deliberately trying to 1.7 to free up. So these are a 0.2, can't tell you in inches, 0.2 millimeter hole and a 0.45 annular. So 0.45 annular, 0.2 hole. And if I go below 4.5, cost goes up. And it's not worth it. Is there a particular reason for the exact position of which ground wires? These ones here? No, I've been deleted. You want as many ground wires as possible, and right now that's not enough. But okay, I can't. It's not about exact positioning. It's you need as much thermal relief as possible. You know, there's only so much. And I can go like this, but it doesn't matter because I still don't have enough of them. That is not enough thermal relief for the chip. not enough at all. See this? Come on, KaiCode, you can do better. I've still got to get this one out. Better be careful there. So I need to get 0, 1, and 2 out. See, look, it's done it again. So the mess it makes inside. Anyway, oh shit, what did I do that for? I need 2 out first. I have to go. Let's not worry about how it looks. Let's just squeeze them in. So I'm 3 and 4 next to 9. No, I need 3 and 4 down the bottom. I need 3 and 4 here because they're ADC pins, and I need ADC pins here. Yeah, no. Where I've got these IO, they have to be there. There's no shuffling the headers. That's the point. That pin here and that pin here have to be ADC pins. And there are only 4 ADC pins on this chip. And they are all 1, 2, 3, and 4. Actually, 5? No, whatever. So, yeah. 5 and 6 aren't. 4 is the last one, I think. So 5, 4, 3, and 1. So I can make it 5 and 4, and I could get 5 out from there to squeeze that up. So it could be 5. That could be 5 and 4 instead, but still, I still have to get them all around. Catch you later, Tishipu. Stack 4 and 3 in the slot next to 9. I have no idea what you're talking about. Sorry. It doesn't matter where I'm putting these at the moment or how I'm routing them out. It's not the point. The point isn't how to get them from here. The point is how to get them through here and leave enough space for vias. Does that make sense? and I need to then get them down, and I have to get them across 3 and 4 because I need to get them out here. It's just unfortunate. And I still need to get other ones from here through as well. Yeah, this is a pain. If I make this 5 and 4, it doesn't change anything. But if I make it 5 and 4, and I have these ones I've not done yet, right? They're wrong. They don't exist. Oh my God. See, it still does those little stupid things. Wow. Nice corner. Well done, KaiCad. Okay, so 5, 4, and then I've got 3, 2, 1, and 0. So it's 4 IO. I don't need 1, 2, 3, 4, 5, 6 IO. So I've still got 6 and 25. Or I've got 24 here. IO 24, which... there are no slow and fast signals. Sorry. Which are slow and which are fast? They're all just signal. And they're all the same. They're all equal. It's not a design thing, it's a chip thing. Like there is no, when you say fast or slow, any IO can be anything. So like if I'm going to do, if I say these are SPI, they won't necessarily be any faster or slower than these pins up here because someone can choose these to be SPI and they can run them at 40 megahertz, whatever they want. I don't have control of that. Sure. But in terms of a microcontroller where pins are broken out, like specifically an ESP32 in this case, where any IO can be any peripheral, there is no some are slow and some are fast. All IO are equal. They can all be high-speed SPI. They could all be nothing pins doing, half a hertz switching. They're all, it's a general purpose PCB. Yep. What was I looking for? 24. IO 24 is probably just nothing special. Right, it's a nothing. It's got no additional functionality. 24. So 24 is it in the mux? Should be. Okay, so I need to get these up. I mean, I can't do this with D plus and D minus. Like I'm going to have to make them, as I said, I'm going to have to bring these. That's not even needed there anymore because there was a 3.3 volt pin there and there isn't one now. So go away. Can you tell the customer which pins are fast routed? No. Well, there are no fast or slow routed. It doesn't exist in this chip. There's no such thing. There's no concept of fast or slow. Yeah. Everything is equal in this chip. It's a chip thing. It's not a Xeon design choice. In this chip, all the I/O are the same. Pin 9. Pin 9. Or you mean I/O 9? What? Looks fast to you how? In where? In the data sheet? I/O 9 it's not fast or slow. Where do you get fast from? So I don't understand fast or slow. No vias. Huh? I don't follow. Or apart from the fact that I/O 9 has vias on it here, but what does vias mean? I could jump one of these I/Os through top to bottom 10 times through vias, and it'll still run 40 megahertz SPI fine. No, they don't. Sorry, Robert, they don't. No. So you mean these two here, 28 and 29, D plus and D minus? It's USB 2, right? They do not need to be length matched, and they can jump through vias. I don't like doing it too much, but they can absolutely jump through vias without any problems, right? They're not USB 3. They're not. So you got to be careful, like, and the length of these are running at, like, I design a lot of these boards. They're yeah. The rules for things like that really have been smashed. They're broken. Some things need them. These USB pins don't. But I won't, like what I'm doing right now, I won't leave them like this, right? Like I don't deliberately do stupid things with them. If the pin is also USB, it doesn't matter. If it's high speed SPI, like when you say it matters and it doesn't, you can make a bad design that's going to affect it badly, yes. But there are just, yeah, it's nowhere near as drastic as that. I promise you. But you're absolutely free to design your hardware however you want to, but there's no such thing as fast or slow in anything that you're seeing here. It doesn't exist as a concept. It's not. There is not one thing on this board here that requires paired, length matched, whatever. That's so high speed that's going to be a problem. You don't understand. I'm saying that D plus and D minus going to the USB do not need to be length matched at this length, and there is no difference in their routing requirements than any other pins on this board. For instance, the D plus and D minus for USB runs slower than the SPI bus can run. So as I said, I wouldn't leave these two like this right now. Yeah. No, it's. Don't worry, you don't have to. Yeah, it's fine. Happy to answer, but I'm explaining there's nothing on this that is high speed. High speed today, like in today's electronic world, high speed is USB 3, USB 4. That's high speed. Not high speed as in you've got USB, all the different names that the USB consortium uses. I'm not talking about that. I'm talking about literally speed. high speed, how fast the switching is, right? USB 2 is not fast in any way. You can abuse your USB 2 traces way more than you can abuse your SPI ones. SPI runs way faster, can run on this chip way faster than the USB runs, right? So things like USB 3, USB 4, or DSI, CSI, MIPI, all those things, they need, or HDMI, stuff like that, they need length matched, you know, paired traces with a lot of respect and no via hopping and stuff like that, right? But there's nothing on this chip, no peripheral on this chip that requires anything, any of those type of concerns. That doesn't mean I'll route it badly, and I won't. But right now, again, this is not about best routing. This is about, can I get everything in, and can I get with the actual required I/O, right? I mean, don't worry about, this is ridiculous what I'm doing right now because I haven't moved these ground pads wires away. So it's going all over the place. But how long have I been streaming? Shit, it's over 3 hours. I'm going to have to stop shortly. I have some stuff I need to make, and I've got a client coming down. Really do not like what SQUiXL is doing with
Super sticker!
Thanks, Robert. You didn't have to do that. I appreciate it, but you didn't have to. That's actually a really funny animation. I've not seen that one before. What is it doing? What's it shaking? That's really funny. No, you're not being a jerk. You're not. You're absolutely not being a jerk. It's, yeah, it's like, yeah. I promise you, you're not being a jerk. And I'm happy to answer the questions. Okay, so, okay, let me, I'll do these traces now. Like, I'm not saying they're going to be exactly here. Why is that doing that? Oh my God. There's something either weird with SQUiXL or weird with my mouse, but there's something absolutely weird going on. Okay, so my D plus and D minus, I'm doing not at the thinner traces, but at the, yeah, of course, you're going to be a jerk. I'm leaving them at a 1.54 just for now. Right, so, and I'll show you what I normally do with them. Really? And this is also pertinent to Wagon Load's question before about USB interfering with SPI and whatever else. So, just hold on. So for my D plus and my D minus, I will normally have a little bit of space between them, right? Thicker than the trace width. Normally I'd spend more time getting them more consistent, right? And then what I do is I make sure that I have, that's not going to fit. Of course it's not. That I have ground stitched around them. So obviously you can't stick ground there, but there's here, and there's there, and then I would have, as much as I can, and then I would put in on the ground, if I don't already have, I'd have a copper pour that either had ground or power around it. Okay, that's a bad corner. I'll fix that later, whatever, right? So when I hit B, don't worry about the unrouted stuff. Oh, interesting. Already had, oh, that's the old one. Right, let's delete that one. So I would be doing something like this. Eight pin chip, 8-pin. Could talk to me in IO, not pin number. But anyway, so I would always ensure that I have ground around. Now in this case, you know, it might be hard to get that solid, but maybe I can. Right. So I would always ensure that my D plus and my D minus has, as much as I can, a stitch ground. Right, can't put Vi there. A stitch ground plane. You see that? And then in this case, it's fine that that's not ground because that's power and it's stable power. If you have a large difference in length of D, then it could. Oh, absolutely, but they don't have to be length matched. Okay, I didn't say you're out. Hi, Iggy, by the way. Theory is that USB traces should be a 90 ohm balanced transmission. USB 1, a 12 megahertz clock rate is ultra forgiving. Absolutely. Right, but this doesn't run at 40. This is, when I say this is USB 2, this is USB 2 at the port, as in it's not USB 3. You can stick into a USB 3 port, but it's recognized as a USB 2 device, but it's not a 480 megahertz USB 2 device, right? It's this. You'd be lucky if the USB on this you can get to 2 megahertz, 2 megabit, right? So it's not running at 480 megahertz. Was my point, and I'm saying they don't like these traces here are not length matched. But that doesn't mean I'm not going to do my best to make them neat and not hop and whatever, right? But like that there is perfectly fine for USB on this device. Yeah. You can get away with way worse than what I'm doing here. And in terms of interference with the SPI on the other side, there's a ground plane and a power plane in between. So you shouldn't be getting interference. Hopefully, shouldn't be getting any interference. But I still have to bring 5 more I/O somehow through here, which I just can't do. So that's not going to help. That's annoying. That's really annoying. Manually setting the distance between the two traces. Have you ever tried? Well, I don't want to treat them as a differential pair. If I actually make them a differential pair, I can't use them the way I've used them. So, yeah, I just am manually pushing around. You run a clock signals, people need to remember they are square waves, and you're routing for all the harmonics. So 10 megahertz per signal is really, say, 100 megahertz to keep it square. Hang on. Yep. But the chip's not outputting at 100 megahertz to make it square. If I set my SPI bus to 40 megahertz, it's outputting 40 megahertz. So I'm not sure what you mean in the case of a micro, Iggy. The only reason it is square is all the overlapping sine waves. Right, okay. But what is the switching on the clock from the chip? What is that physically outputting? Regardless of what it's doing internally, it is outputting. If I set it to 40 megahertz, it is outputting 40 megahertz, right? Whatever it does internally to have it be square. So anyway, this can't be routed, and keeping it compatible with the tiny C6, tiny S3, tiny S2, tiny Pico. It's just not going to happen. So, that is frustrating. Very frustrating. It's okay. I didn't want to make another board anyway. As in another product. Another SKU. It's happening for me, but if you put it through a 40 mega filter. Thanks, Iggy. I've stopped routing now. I can't route this. So, yeah. I can't route this board and make it compatible with my tiny series boards. So, unfortunately. Not fully compatible. I'd have to start making compromises. And that doesn't include the I/O I need to connect to other things like the VBAT sense. This particular board doesn't have the fuel gauge on it. It's an older design. So even with the fuel gauge, I still need interrupt pins and whatever, which means that there are still 2 or 3 I/O that I need to go to VBus Sense and the battery. And I don't think I'm going to have enough anyway. I think I'm going to be 1 pin short, and I can't make it compatible on the headers. No. It's not a routing issue. It's I could rip the whole board up, rearrange everything on the board to try to route it. It's not worth it because, again, I've already got a tiny C6 board in the marketplace. Making a tiny C61 board as well. Ugh. So, not worth it financially to go to a 6-layer board. And before you tell me that 6-layer boards at JLC are cheap, yeah, they're cheap for a prototype little board. When you go to panels, they go back to full price and they're very expensive. And the issue with 6-layer boards, I mean, I've discussed this in the past. The challenge of routing more layers is it'll give you more space for traces, yes, but for me, most of the time, my bottleneck is via placement. To use extra layers, I need to put extra vias, right, to get to those layers. And, you know, as you can see here, I don't have room for vias. I can't put this, okay, for argument's sake, I don't know where, I don't know where I could show you like a specific example. Sure, I could put these ones here on a different layer because they're already got vias and bring them back on a different layer. Absolutely, I could, yes, but it's not worth it. Like, again, the Tiny C61 is a product that doesn't make a lot of sense to me shipping, right? And just because it's the only difference between it and my Tiny C6 is 2 mega PS RAM. That's it, right? Yeah, I already have, all my boards are 4 layers. So again, ground plane, power plane, traces on the bottom. Sorry, traces on the bottom, power plane, ground plane, top plane, signal, ground. So yeah, already doing 4 layers. 6 layers is, yeah. There's only one board I've done as a 6-layer board, which was that my Blizzard board, which was the ESP32-S3 and the Ice 40 on it. But a lot of the time when going extra layers is the via. Yeah, all good. Yeah, I don't do RF on boards that aren't 4 layers. RF on 2-layer boards is, yeah, not great. Anyway, I've got a footprint, I've got a schematic symbol for it. I'd rather, you know, look at where else I can use it rather than making another development board. I just thought this would be the easiest thing to spin up if I was going to test the chip. Not that I can test it because there's no C61 support yet anywhere. Only been on board, boot, and double-sided, not normal. It's 2 versions of 4 layers. You mean they just use different FR, the different substrate, the different like material they use? What do you mean 2 versions? 4 layers is 4 layers. It's whether you're using high temperature FR4, low temperature FR, it depends on what the requirement is, but it doesn't change the 4 layer. It's still just a 4-layer board with whatever stack up. So it won't make any difference to being able to route differently. If I want to be able to route differently, I need to go smaller vias, which really jack up the price, massively jack up the price. Because remember, I'm not making a board by itself, I make panels. And so panels means the more vias you use and the more expensive the vias are, the process is they extrapolate the cost across the size of the board. I only ever use standard FR4. None of my stuff needs high layer.
Disconnected.
None of my stuff needs high temperature. Sorry, not high layer, high temperature. Standard, whatever their standard, what is it? Oh, I can't even remember what it is. But yeah, the lower temp, fine. No, I'm not close. Not close at all, actually. So I need to get 1, 2, 3, 4, 5, 6, 7. I need to get 7 more IO over to that side. 7. And I don't even think I've got 7. 1, 2, 3, 4, 5, 6. Well, there you go. I need to get 7 over, and I only have 6. No, it's not. Whipping it up won't help. Do you hear what I just said? I need 7 IO over, and I only physically have 6 IO available. So that would mean unroutable. I can't manifest an IO out of nowhere. Check in 1, 2, 3, 4, 5, because I got 24 out. 6, 7. Yep. I'm going to add a coprocessor for 1 IO. Yeah, no. I mean, I could put an IO expander on there, squeeze an IO expander on, but not for the headers. They have to be native IO. But still, same problem. So but the problem, if I put an IO expander on, I need at least an interrupt pin on it. So that's I still need a native IO, 1 IO for that, and that could free up 2. That could give me my 6, but then the cost of the board goes up because I'm putting more parts on it. And again, I don't need this board. I don't need it. It was I wasn't looking at making a product out of it. What I want to do is use the tiny C61 on a lower spec watch, like a tiny watch C61. Okay, one more time, just for fun. I have 6 IO left available to me, 6, and I need 7. So it doesn't matter if I route the 6 over. I am missing an IO. Missing an IO. And if I was going to make this board, I'd want it to be a Series D board with the dual antenna, which means I'm missing 2 IO. So I can't make 6 equal 7 or 8. And it doesn't matter if I make the board 5 times bigger to give myself lots of routing spaces. I'll go 12 layers. I can't physically make 7 IO, unique native IO, out of 6. So, thus ends the board design. Folks, it's been fun. 3.5 hours. Still 27 people watching. Really? No way. Thanks for sticking on this journey with me today. I will use these. I'll find a use for them. And it won't be with an AMOLED screen because there's not enough I/O. Just saying, in case anyone's going to ask. I'll fix it in the software. Yeah, I'll just leave one of the headers. We're talking about header compatibility, but I'll just leave one unrouted. Yeah. I'm not solving this by sticking an I/O expander on it. It's a board that I understand you all want me to finish routing it for the challenge, but it's a board I'm not going to ship. So it's a board I'm not going to prototype. If I could get it routed, if I could get everything routed on it, I would prototype it just so I'd have something to play with on the C61, but I wouldn't ship it, right? Because it's a tiny, it's one of my product range. I have a range of boards called Tiny whatever, and they are all pin compatible. So I can't make this a tiny board and have it not be pin compatible. Simple as that. All of my tiny boards are interchangeable, and if this is not going to be a tiny board, then it's not going to be a board I make anyway, because I don't want to introduce a new form factor board in my range. So it's either a tiny board or it's a nothing board, and it can't be a tiny board because I don't have enough IO. Anyway, it doesn't matter. I know everyone wanted me to get it routed and finished it for the challenge. I like a good challenge, but in this particular case, it cannot be a tiny board, so there's just no point finishing it. But as I said, for those that remember, they're still around, before I made my tiny watch, where's my tiny watch? Oh, buried. Before I made my Tiny Watch S3, this was going to be a Tiny Watch C6. But the C6 didn't have enough I/O and didn't have any PSRAM and didn't have enough SRAM to do anything nice on the screen. Tiny C61 will be a perfect fit to make it'll have to be a lower spec because there's not enough I/O, but to make a watch. And that's what I'd rather use the Tiny C61s for. So maybe on next week's stream, I'll look at the watch. But it's going to have to lose a lot of its peripherals because there aren't enough I/O. Yeah, here's the path. I don't want to add an I/O expander on there, Wagon Loads. And I wouldn't. If I had to solve this board by putting an I/O expander on it, then it's a board I shouldn't be making. I'm not saying I can't solve it. I'm saying there's no point. It won't be a tiny compatible board if I do. So there's no point. Like, yeah. It's not necessary. Okay, I'm going. Thanks all for joining. Thank you to all of you that did super chats and whatever. I much appreciate it. Appreciate it muchly, whatever. I'm going to go get a coffee and get to work. I've got a client on their way. So thank you all. Have a great week, and I will catch you all next week. Bye.